Number 3. A bicycle tire is inflated to 55 pounds per square inch at 15 degrees Celsius. Assume that the volume of the tire does not change in any appreciable way once it is inflated, like it doesn't leak at all. If the tire and the air inside it are heated to 30 degrees Celsius by road friction, does the pressure in the tire increase or decrease? Again, assume the volume of the air in the tire remains constant, right? It's a nice, big, thick tire, doesn't expand or contract. The pressure will increase as the temperature increases. We've had a 15 degrees Celsius increase. And if the volume of the tire isn't going to change, because the question just told us that it's not going to, assume the volume of the air in the tire remains constant. The only thing that's going to be able to increase to maintain this relationship is the pressure. So the pressure is going to have to increase as the temperature increases because we have fixed mass and fixed volume. Now, B asks you a tricky question. Because the temperature is doubled, does the pressure double to 110 pounds per square inch, psi? Well, the pressure does not double, right? So that's what the question's asking me. Does the pressure double? No, the pressure does not double. Because an increase of 15 degrees, right, from 15 degrees Celsius to 30 degrees Celsius, it might seem as though it's a doubling of the temperature. And on the Celsius scale, you're right, we just doubled the temperature. However, when we do gas law calculations, when we use the gas laws, we have to use the absolute temperature, which means the Kelvin scale. And so if we look over here for these conversions, the first temperature, 15 degrees Celsius, is 288 Kelvin. And the second temperature, 30 degrees Celsius, is 303 Kelvin. You notice that this is not a doubling. This is not a doubling, right? We would have over 500 Kelvin if we were to actually double this temperature. And since we did not double the absolute temperature, we do not double the pressure. Then C moves on to ask, what will the pressure be when the temperature has doubled? Explain your answer in pounds per square inch. All right, so when we do have this change from 288 K to 303 Kelvin, what will the pressure be? Because we just said that it's not going to double. Well, we rearrange our equation that relates pressure and temperature, which is Gay-Lussac's law, to solve for P2, the second pressure. And we have P1 times T1 divided by, P1 times T2 divided by T1. And so we look at the numbers that we have from the problem, and P1 is 55 pounds per square inch. That's from the first part of the question. T2, the second temperature, is 303 Kelvin. And then we divide by T1, which is 288. And the calculator is going to tell you 57.865, but we're not going to use that many significant figures. We're going to use two significant figures. So when I look at 55 pounds per square inch and 15 degrees Celsius, two significant figures. So I'm going to record two significant figures. So that means I'm going to round to the 7 right here, but this 8 right behind it tells me to round it up. So I'm going to report 58 psi.